All right, this is Math 2, Lesson 842, Arcs and Sectors. So we're going to figure out what arcs and sectors are. They're both parts of a circle. The circle is called sectors and arcs, and we're going to learn about how to figure out the measurements. We're going to be talking a lot about pizza today because pizza is circular and it's easy to talk about pizza and these two concepts. So to celebrate their victory, the girls' ice hockey team goes out for pizza. The goalie eats half of a pizza that has a diameter of 20 inches. The diameter is 20. She has eaten half. So she ate half of this pizza, diameter of 20 inches. What's the area of the pizza that she ate? The question is, what is area? So that's what we're trying to find out. What is the length of the crust that she ate? And leave your answer. So we have two questions. What is the length of the crust she ate? And what is the area that she ate? So we're going to go with first area, then crust. Length of crust. Okay, so this is a fairly straightforward process. Area, crust. Go. Okay. So for area, we'll use this. Since it's half the pizza, we're going to do half of the area of a circle, which is pi r squared. In this case, r, we have a diameter. D is 20. I'm going to write that up here. D is 20, which means r is 10. So the area is going to be 1/2 pi times 10 squared, which is 100. Half of 100 is 50, so this is 50 pi. So that's the area in exact form, 150 pi, inches squared. Okay. Then we have length of crust. So since it's the crust, that would be an edge. That's circumference. So circumference. So with the other one we were dealing with area, and this one we are dealing with circumference. So we're still going to have half. The formula for circumference is 2 pi r, or diameter pi, whichever one works to float your boat. And so both of these, let me go back here, put these around. So this, r is 10, so that's 20. 1/2, let's plug in 2 pi times 10. And 2 pi times 10 is 20. 20 divided in half is 10. So this is 10 pi. But this is just inches because it's crust. Inches squared. And that's really all there is to it. So the tricky part generally is actually finding this fraction more than it is anything else. So we're going to continue with this, doing the two different things for each problem because it's asking for both again. All right, so Sonia chooses a slice from another pizza that has a diameter of 60 inches. So D is 16, so I'm going to go ahead and write this down. D equals 16, which means R is 8. Central angle of 45 degrees. So here's the tricky part. Central angle of 45. So the whole circle is 360. So we've got 45 divided by 360, which is 1/8. Okay. And so to find the area, I'm going to take 1/8 of my area, which is pi r squared, pi times 8 squared. So 8 squared is 64, 1/8, 64 pi, and 1/8 of 64 is 8 pi, and 16 inches, so inches squared. And that's really close together. We'll move the blue line anyway. Inches squared. Okay. Then for the crust, this isn't going to change. So we're still going to have 1/8. My circumference is 2 pi r, which is 8, which is equal to 1/8 times 16 pi. An eighth of 16 is 2, so 2 pi inches. That's up. As the evening draws to the close, Sonia notices there's only one slice of the goalie pizza remaining. She estimates the central angle to be 72 degrees. Using this estimate, what's the area and what's the length of the crust? So we'll start by figuring this out, and it's the goalie's pizza. Since it is the goalie's pizza, R, if you recall, same pizza here, R is 10, and G is 20, goalie pizza. For the angle for this fraction, I'm going to put 72 over 360, which is equal to 0.2. 0.2 is 1/5. I like the fractions better for this than the decimal. You can use whatever you prefer. But for exact answers, I think the fraction is easier. So let's go ahead and do our area. And so area is 1/5 pi times 10 squared. So 1/5 of 100 pi. 100 pi times 100 divided by 5 is 20. So 20 pi inches squared. There's our area. For our length of the crust or circumference piece, we will have 1/5 of 2 pi times 10, which is equal to 1/5 of 20 pi. I wrote 1/2, I meant 1/5. And 1/5 of 20 is 4, so this is 4 pi inches. Okay, so what have we been doing? So we've done these 3 examples. We found the areas and the lengths of the crust of these pizza sections. So what have we actually been doing? Okay, what we've actually been doing is a portion of a circle, like the crust of a slice of pizza, is called an arc. It looks very much like an angle, but it's just the arc. Okay, and we're asking how long is this arc? If I straightened it, took this and straightened it, well, how long is it? This is a set of connected points that's a fixed distance from the center point. The length of an arc is a part of the circle's circumference. That is really, really important. The length of an arc is part of the circle's circumference. Part circumference. If a circle has a radius of 6 centimeters, what is the length of an arc with a central angle of 30? So, radius of 6, so R is 6, central angle of 30, 30 divided by, that's how much do I have? 30 over the whole. Part over whole. 30 over the whole is 3 over 6, 36, which is 1 over 12. And so I have 1/12 times the circumference, which is 2 pi, in this case 6. So I end up with 1/12 times 12 pi, which gives me pi centimeters, is my arc length, or portion of circumference. Okay, so what then is our formula? Central angle, that's spelled wrong. That's good because I need to put a word in front of it. Measure of central angle, central angle, central angle. Let's do the angle symbol. We don't usually draw the arcwork in it. Measure of the central angle, which we're going to call M. Okay, so divided by 360 times the circumference. So what that means is portion of circle, part of circle I have. And that will always be a fraction. M will always be smaller than 60 unless I'm finding bunches of central angles with multiple circles. That's rare, right? And then this is the the circumference. Which is why it's so important to know that it's part of the circumference. Circumference times the portion I have. A region resembling a slice of pizza is called a sector. Let's go with green. Pizza is called a sector. It is bounded by two radii of a central angle and the arc between their endpoints on the circle. So the arc and these two pieces. So the crust and the cuts, the pizza cuts. If a circle has a radius and its part, this is part of area. So arc length is part of circumference, and sector area is part of area. A portion of the area of the whole. Okay? And so this has a central angle of 20 and a radius of 10. So R is 10. My angle M is 20. So we've got 20 degrees divided by 360 equals 2 over 18, which is 1/9. Okay. Oh, 2 over 36, excuse me. 2 over 36. My brain jumped too quickly there. 2 over 36, which is 1 over 18. I caught that before I kept going. So we're going to take our fraction times our area, pi r squared, and r is 10. So that will be 1/18 times 100 pi, which is 100 pi over 18. 2 goes into both those numbers, so that's 50 pi over 9. And I'll leave it there. 50 pi over 9 feet squared is the sector area. What's awesome about this is that using the same I am not sure where this froze, so apologize if I repeat myself. We were here. We simplified it. If I had this written down when I looked at the screen. So 50 pi over 9 feet squared, which is the sector area. Okay, so we took this, divided, simplified. And we'll leave it like this. They want an exact answer. This is it. No decimals. No decimals. No decimals. All right. So we're about to move into the formula. Using the same letters, measure of the central angle for m degrees divided by 360, times, in this case, pi r squared, or in other words, the part of the circle times the area. So part times whole. Part times whole. That's it. That's all there is to it. So that's not too complicated, and to me it makes perfect sense, but I know that it's hard to remember which is which, or maybe we're not comfortable with these formulas. Certainly we're not comfortable with the answers in terms of pi. We need to get over both of those problems. Let's go ahead and take a look at the back side of this worksheet and see what else we can accomplish with the work we are asked to do today. Use the sectors in circles D and E to answer the following questions. So these are sectors. We can find the area and the arc length. Okay. So What is the length of the arc marked for each circle? Leave your answers in the exact form, in other words, in terms of pi. So what is the arc length of this? So r is 3. So we'll call this circle 1. And this one's circle 2. R is 3. R1 is 3. Okay. The angle is the same for both, so that's nice. M is 30 degrees. Okay. So I'm going to take the portion of the circle, 30 degrees, divided by 360. This simplifies to 112. We did that earlier today. 112. And then we're going to take 112 times the circumference, in the circumference, so 2 pi r. R is 3. Okay, so that leaves me with 6 pi over 12, which is pi over 2. For the other circle, it's still going to be 112, but now R2 is 5. So 112 times 2 pi times 5. So 112 times 10 pi, which equals 10 pi over 12, which is equal to 5 pi over 6. And that would be, so that's it. This is just units, whatever the units are. It didn't give me any units. So those are my two answers, and I am finished. What is the ratio of the arc length to the radius? Ratio of arc length to the radius for circle D, which we call circle 1. Okay, ratio of the arc length, so the arc length, pi halves, to the radius, we're dividing. Which is pi halves times 1/3, or pi 6. For circle E, what is the ratio of the arc length to the radius? So arc length is 5 pi over 6 divided by the radius, which is equal to 5 pi over 6 times 1/5, which is equal to 5 pi over 30, which is equal to pi over 6. Now I could have just crossed off the 5's back here. I thought I would go out here for you guys. Notice that the ratio is the same. Suppose circle F, another circle, third circle, has a radius of 100 units and an arc length with a central angle of 30. What is the ratio of the arc length to the radius for the circle F? Show your work. So first we need to find the arc length. R, I'm going to use sub F, is 100. And so but the fraction is still 1/12. 1/12 times pi, 2 pi times 100 equals 1/12 times 200 pi, which is 100 over 6. So let's actually go 4 into both those numbers. $50 pi over 3. Double check that. Yep, okay. There's my arc length, and so then I'm going to take my arc length, 50 pi over 3 divided by the radius, 100, leads to 50 pi over 3 times 100 times 1 over 100, which is 50 pi over 300. Divide 50 into 300 and I get 6 pi 6. Notice it's always the same. There are other units of measure besides degrees that can be used to measure an angle. For example, radian measure, which is what is being introduced here. Radian measure of a central angle is the ratio of the arc length to the radius of the circle. And so all central angles of 30 have the same radian measure. Because look, they did 1, 2, 3. Because that ratio, let's actually back up to this one right here. So 2 pi times 100 over 12. And I'm dividing by 100. And so I will get 2 pi over 12 because the hundreds will go away. Let me do that a little slower. Because the 100 goes here and goes away. And so 2 pi over 12 is always pi over 6 every single time. So what happens is I'll have 2 pi over 12 for every central angle of 360 times the radius divided by the radius, or 1 over the radius. And so r will always go away. And I will just be left with pi 6. And that's it. Hope you have a great time. Sorry this video is a little long. We'll see you guys soon.